Hi, everybody. Welcome to the Ekotrope webinar. Over the next 30 minutes, you'll be listening to myself, Bill Flynn, Vice President of Ekotrope, and Adam Newman, who heads up our business development. We'll be covering the following subjects. How did Ekotrope get to where they are today? What builders have been telling us over the last couple of years? How is Ekotrope different? We'll then go into a live demo with Adam, and then if we have some time at the end, we'll answer some of the questions that you pose to us. Okay, here we go. Ekotrope is a software tool in the cloud that was started through a relationship between MIT and NASA. Our co-founder was asked by the Bush administration to help us get to Mars. What he did is created a program that allowed the mission to be seen as one system, to make it as efficient a system as possible. We then applied it to the housing industry because the founder of the company was building a home in Idaho, and in that process he was trying to build an energy efficient home, but not trying to break the bank while he was doing it, and he couldn't find a good way to do that when he talked to the builders, the designers, the energy consultants, etc. So he took his technology that he built for NASA and applied it to his own home, and that's how we were born. What we did is we took the technology and wrapped some software around it. Along the way, we became a nationally accredited HERS rating tool by ResNet, also became Energy Star compliant, and we were performance certified for IECC 2006, 2009, and 2012. What we found over the last year or so when talking to builders is there are three main themes that come up often. One is that we help them to design in a much faster fashion than they were before in the planning process. We've heard things like it's processes that used to take us weeks to months now take us hours to days to do. We've also found that we can help reduce construction costs in a significant fashion. We are finding consistently that we're able to generate savings that were unrealized before of hundreds to thousands of dollars per home in energy and construction costs, and even more so in communities for production builders. And lastly, we help increase home value. We have done this in a variety of ways. One way that we found is that we allow folks to do energy upgrades that have a significant amount of profit in it for the builder, but are also extremely cost effective for the home buyer. So it's a win-win for both parties. What we found over our conversations with the builders is that there seems to be a general way that most builders do building design today. Your particular process may vary, but here's what we found for most is that they start with a previous design, something they're very comfortable with that they've done in the past. And in this particular scenario, we're looking at the capital cost of energy-related components on the x-axis and the annual utility costs on the y-axis. So in looking at how they can be more efficient, they may find a better component that improves the design. It costs them less money to build. Then they may look to an energy consultant who may find some other savings in terms of energy. And they may go through this process a few times, but after maybe 3, 4, 5, 6 times, they settle on a particular design, and that's what they go with. What we found in many cases, in this particular case, a builder that is very familiar with building a number of different wall types, 6 wall types, 5 window and roof types, 4 furnace and air conditioner types, based upon their experience, have many, many other ways that they can build that home that they haven't yet been able to see all of them in one place, and that's what Ekotrope does for them. Now this design option set is certainly very large, and so the next step is to filter it down. In this particular example, we are filtering it down by code first. So let's say this is 2009 IECC code for this particular builder. There are a number of designs that are above the line which are not acceptable, and they fall outside of the code specifications. But there's certainly a number of other designs that fall below. And first, let's look at maybe a reduction of cost. So there are a number of designs that are less costly yet do meet code. So this particular builder, if they wished, could build the same home in a different way, saving, in this case, probably thousands of dollars. The next scenario we can look at is energy savings. In this example, you're looking at the code that the cost stays the same. You still meet code, and even then some, with the extreme energy efficiency on the next step. And then lastly, they may pick something in the middle where they're saving money on their own that they can put into their pocket, but also building a higher performing home. Now, next step, let's say 2012 code comes along. The particular design that they have chosen does not meet that code, so they have to look to other ways to build this, and Ekotrope has already set them up for that, saving them certainly lots of time and effort. So you can see that one of the designs that we picked in energy efficiency does meet that future code, but there are also a number of others that fall to the left that are also less costly, which they could choose as well. Now, Ekotrope is not a recommendation engine. We don't tell you which home design you should choose. Our job is to lay out all the different options for you, and based upon your business goals of either profit or energy efficiency or marketability, you can decide what you'd like to do with that particular building design. Now, having done this over the last couple of months, we've worked with a number of builders and are going to show you 5 different examples of things that we've done over the last few months, as I mentioned. First is in construction savings. As you can see, we've saved some builders up to almost $3,000 in construction savings, as well as in energy savings. We've been able to find an increase in efficiency, and actually in builder number 3, we've been able to find them about $1,300 in construction savings and about $775 in energy savings. So as I said before, we can consistently find these types of savings for many builders. These builders vary in terms of size. One of these is a top 5 builder. We have also folks all the way down to some builders who build about 20 to 25 homes per year. So it's certainly a variety of folks can benefit from Ekotrope. Now, not only can we optimize the home from an energy efficiency and or cost perspective, we can also help production builders optimize their communities. In this particular example, we're looking at a baseline community that have 5 different plans associated with them, plans 5 through 9. And what we did for this particular builder was find a baseline component set that works across all of them, so they don't build the different homes in different ways, making it a less efficient process for them. In this case, we actually were able to find about $900 of extra value for this sets of plans for this baseline community. In this scenario, let's say it's a cost savings of $900 per home. However, what we can also do is look across the different sets of plans that you have access to, just like we would with the components, and maybe find the optimized community, where in this scenario we replaced plan number 9 with plan number 10 and kept 5, 6, 7, and 8 the same. When we did that, it was a different set of components that were available and optimized for those plans, saving this particular builder an extra $600 per home. So the total value in this scenario of this optimized community is saving $1,500 per home for this particular buyer. Thus, the baseline community was optimized for a particular set, but not fully optimized in terms of construction savings, which we provided for another set of things. The process that we go through to get all this information, all the results that we have, is a 3-step process. You have component input, where we will help each builder build a component library with multiple options for each type of component. You only have to do this once. You can certainly add other components as you go, but the baseline component size starts off and can be done once. Then you have plan input. If you want to do it in a digital format in CAD or SketchUp or Revit, we can do that very easily and quickly. But if you only have things in PDF form or some other paper format, we can do things on a manual basis. Once you have all the components in and the plan input, then you push the button and you optimize your design. You can find your most cost-effective designs that meet your goals. Number of goals that we've seen across our builders are represented here, where we've already talked about you can reduce your costs, you can increase your energy efficiency, you can have no-brainer upgrades for clients, meaning that you can drive energy options that save the consumer dollars in terms of their energy bills, but also highly profitable for the builder. You can increase your competitive advantage where you're building your home and comparing it to other homes in the area that the buyer may be looking at, and showing them how your home is a better buy over time for them. Or lastly, quickly analyzing a new component. Many of our builders come to us and say that they get component requests all the time from manufacturers to have them try things, and they never know which ones are the ones that can be used best. Our software easily lets them add that to it. We virtually build the home on their behalf and let them separate sort of the wheat from the chaff and pick only those components that may have an opportunity to be beneficial and have further conversations with those particular manufacturers. And then lastly, they choose their final design. Now, once they do that, they have an opportunity to build the home, but in order to do that, they have to sort of go through the software, and I'll ask Adam to pick it up from here and go through a more detailed process of how a particular builder would use the software and optimize it for themselves.
Fantastic. Thank you, Bill. I appreciate this. Just for everybody, this is Adam here, Head of Business Development, wanting to give you an opportunity to actually show you how all this comes together in our software. So switching over here to our software, you'll notice that this is a completely web-based tool, that there's nothing to download. All the newest updates will come directly to you via the web. So you always are working with the most up-to-date and advanced version of our software, nothing more to download or pay for. And it allows us to run hundreds to thousands of different options in just a matter of seconds or minutes, not having to rely on a particular computer or an old laptop. Anyways, what I wanted to get into a little bit more specifically was exactly how this process that Bill had just gone over works inside of our software. So as you'll see here, we've got three distinct areas. Our project component library here, our initial building design, which includes our geometry here, as well as any incentives that are specific to this area or location that you might be building in. In this particular case, I wanted to show you a particular building that we optimized for a builder in Phoenix, Arizona. We've got the climate zone and as well as the particular location that this is being built, because this is actually going to pull in all of the local weather data as well as local incentives and local utility costs for us to be able to utilize when running our simulations. Going in a little bit more detail, our project component library consists of all of your unique energy-related materials. So for instance, glazing walls, your mechanical equipment, any slab insulation, frame floor insulations, roofs, different air sealing techniques. You might even want to do net zero houses with us. That's something that we can do as well. So going in a little bit deeper, as Bill had just mentioned, there might be an opportunity that you've got different components that you might want to look at. Here I've dove one level deep into looking at our conditioning equipment. We've got our heating and some of our cooling options that the builder had at their disposal. However, there was another component that I wanted to show you, and it is simple as this to add a component to your library, a new heat pump water heater. This is something that's costing about $1,300 to put in, and the builder was curious to see if this was something worth spending some extra time on. We can simply import this into our library, and we can see here that we have just imported this particular heat pump water heater into our project library so that we can utilize this in our analysis. And this goes really with anything you've seen here, walls, windows, lighting, etc. All of this can be updated to your particular costs with your particular materials and different types of materials that you might want to consider. The second part that we have working for us here are the incentives. So in this case, I chose just a couple of the incentives that are applicable to this particular builder, a federal tax credit for solar, PV, as well as using a tiered energy code rebate for Energy Star and HERS scores. This might be similar to your particular location that you're building in, However, they're constantly updating this list so that you can choose them or easy to add them here as well. And finally, we have our initial design. Our initial design meaning how is the builder building this particular model today? We can see in this case, this is a 1,700 square foot home. You can see here, it's a 3-bedroom home with slab on grade construction, 1 floor above grade. We then go into more specific allocations of space, so your envelope, your windows, your mechanical equipment, your lighting, etc. And what we can see here is that the initial capital cost to the builder for these energy-related materials only is about $16,000. Her score of 62. Wonderful. Question, however, is, are there other ways that we could construct this very same home? And as we will see, we can. By clicking on this Variations tab, I can start to get into looking at the different materials that were in my component library. So for instance, I could build this house with different types of roof insulation. R38 was how it was spec'd originally, but maybe we could do R30 or R19, different above grade walls, different glazing opportunities, different furnaces, and different hot water heaters and air conditioners. But again, I had mentioned before when I imported this GeoSprings heat pump water heater, the builder was curious but didn't really know if it was going to help. So why don't I include that in our analysis as well? I will also choose on the different code compliance, Energy Star, HERS, IACC 2012, and 09 code. And now I have basically chosen 648 different ways to build this very same home, looking no different to the homeowner, but as we will see in just a moment, will perform and cost very differently. What our software does during this analysis, as you're seeing going on right now, is the software will build virtually 648 different homes, taking hourly weather data for an entire year, utilizing the Department of Energy's analysis of the price escalation for the next 30 years of the particular utilities, and put all of this together with the possible incentives that these particular designs might qualify for, so that you can see a customized scatter chart with all of the costs, all of the annual energy bills, and any energy-related metric, so that you can find what is the most cost-effective and energy-efficient design that one might want to build. I've pre-baked this here for us, so we don't have to spend the additional 45 seconds or so waiting for this to complete. And we can see that we have a customized scatter chart with our initial design here with this red star in the middle of all the other possible designs that we have. So again, cost on this horizontal axis versus annual energy bills for the homeowner on the Y vertical axis. However, this particular builder was not only concerned about IACC 2009 code, but they were more concerned because they needed to meet the 2012 code. And by clicking on these filters, I am actually reducing, as you just saw, the number of designs that will meet or exceed that threshold. In addition to 2012 code, this particular builder wants to build to Energy Star standards 3.0. By choosing that filter as well, I will further reduce the number. And what you can see here is these are all possible designs that the builder has that will meet or exceed their particular energy goals. Quickly, we can identify that there are actually opportunities here for not only reducing in cost, because cost increases from left to right in terms of capital costs of the builder, but the energy bills are actually increasing from bottom to top. What I can quickly identify is that if this is the initial design for the builder, this particular design here, when clicking on it, I can interact with it, any of these designs. I can see the preliminary HERS score, I can see the capital costs of the builder, any incentives that they might qualify for, as well as the annual energy bill. If I scroll down a little bit further, I'm going to actually get the particular component and equipment that went into this design so that a builder can take this and start building and go vertical. What I can do here so that I can look at this in a side-by-side comparison a little bit later is I can save this design down. And again, this was meeting IACC 2012 and Energy Star. I can save this, and what it will do is highlight this and make this a star of favorited design on my graph. I wanted to show you another option. If we hadn't considered the GeoSpring, we can see that there were some designs that are removed from this particular graph. By choosing this GeoSpring heat pump, we actually found that there were some better options that might not have been considered if a builder was not using Ekotrope or didn't consider this GeoSpring's heat pump water heater. Although it might be a little bit more expensive, there might be other ways to save money in other energy-related materials in the house, but overall you're saving more or being more energy effective at the same time. So, for instance, if this particular builder wants to maintain this particular level of energy efficiency, we can move directly left on the graph and choose this design, which again, I believe includes this GeoSpring water heater. This HERS score is a HERS 60. We can see that it qualifies for additional incentives, and it's about as equally as energy efficient as we were when we started. I will save this down as well. I'm just going to name this as a cost-effective design so I can remember what it was when I come back to it. But interesting here, we can not only just look at cost versus annual energy bills, we can look at cost versus HERS score. So if this particular builder is going after a particular HERS score, in this case they were hitting a HERS 62 if you remember when we looked at it initially, we can see that they're certainly not building an optimal HERS 62 design. As a matter of fact, this particular design here would do that. But we can quickly identify that that particular design that I just saved down was even more cost effective and a lower HERS score. So in this case, the builder gets to be more cost effective and more energy efficient at the same time. I'll pick one more design so that we can see a full spectrum here. Let's choose a design that is not as cost effective necessarily compared to the baseline, but is more energy efficient. This design might suit. So what I'm going to do here, we can see a HERS 55, qualifies for different levels of incentives. I'm going to save this down just the same, calling this a more energy efficient design. Having done that, what I can do is go back to my project and actually look at all of these side by side. Software will do is essentially do a hybrid of what you can potentially do in Excel today very quickly and easily. So for instance, if my initial design here is the furthest to the right, I can see that when doing this analysis, and you saw in real time how long it took, just a few moments, we could find areas that were saving about $2,400 in upfront capital costs to the builder. Significant amounts of money, especially if you're talking to a builder that is building, many houses per year. Also, will meet their IECC 2012 and Energy Star levels that they need to meet because of code or because of marketing. We also found a design here, if you might remember, a more cost-effective design that was actually better HERS score than their original 62 and saved them about $1,100 in upfront construction costs and was similar in annual energy bills. $11 a year more expensive on annual energy bills, about $1 more per month, a bit negligible. If we look here, we can also find a design that was a little bit more expensive up front. However, because it qualified for more incentives, was overall $400 less expensive to build and saved a homeowner over $100 a year in annual utility costs. And in the lifetime, over 30 years, will save a homeowner $5,000 or a little bit more in the long run. This might be a much better design that a builder could use and potentially charge more for in the long run. If I scroll down a little bit more, we get a breakdown of the energy environment. We also will get a side-by-side comparison of the particular design components. So in this case, the software will highlight all of the areas that changed in the particular designs. So for instance, with the initial design, we started off with an R38 blown fiberglass in the attic. What we can see is that our more cost-effective IECC 2012 and still Energy Star compliant home went with an R19 blown fiberglass instead, saving us some money. Scroll down a little bit farther, we can see that glazing changed as well. Our more energy efficient option went with a low E with argon rather than staying with our just low E option. scroll down a little bit further, we can see that additional changes happened in the AC. We can see that we started off with a 14 SEER, and we've got a full spectrum. We've got our most cost-effective utilized the 13 SEER, the same capacity and tonnage as before, however, just a different rating on the SEER level. We can also see that a more cost-effective and lower HERS score used the 15 SEER, and our most energy-efficient design that we chose real quickly utilizes a 16 SEER. If we go down, we can see that we were originally using a gas 40-gallon water heater. However, what's interesting, when I looked at that GeoSprings, we also found that this GeoSpring water heater that we were considering to see if this had some type of impact on our design, in fact does. It allows us to achieve greater savings while also being more energy efficient and having a lower HERS score. So that was utilized here in this second design. In our most cost-effective, it didn't change from our baseline. So that is a quick overview of how Ekotrope works. And what I'd like to do is just answer a couple of the questions that were asked during our presentation. One of the questions was asked, are the costs national averages or location specific? And this is a great question. All of our component libraries are actually built up in association with our builders, so that we are using their true costs of components and labor for the particular components that they are considering. This is a very important point because we want to look at most accurately the different changes that a builder can have and what really is utilized on their behalf within their particular component set within their library, because there might be some opportunities that have been overlooked that are very easy for us to identify with our software. Another question that was asked is framing design optimized by the Ekotrope software? And this is certainly the case. In this particular example, we did look at 2x4 versus 2x6, and we look at the variations that includes, whether it be different cavity insulations or exterior insulations. We can also do this with different types of truss systems, whether you're going with an open truss or different types of systems. We can very easily identify opportunities to potentially some truss systems allow us to put more insulation in, others will not. What type of insulation can we do? Maybe the flat attic versus the cathedral ceiling, etc. So we certainly have the opportunity to do that. Another question is, for energy savings, does the software account for any yearly increase in energy costs? And that is a very good point to bring up. In fact, it does. Our software utilizes about 30 years of back testing done by the Department of Energy to estimate the price escalation of utilities based on your specific zip code that you're building in, so that you can see not just what the cost savings will be today, but what the lifetime savings will be for the next 30 years, or whatever term of ownership your particular homeowner is looking to do. Last question is, how much support do we give? Our software is set up so that we will provide you with the full suite of service at least for the first 6 months, so that you get all of us doing everything soup to nuts for you, from inputting of the designs, to the optimization, to reporting, etc., for the first 6 months. After that point, what we do is not only in the first 6 months will we work with you to bring you up to speed, but provide you with any of the additional support or auditing capabilities that you require going forward. So again, on behalf of Bill and myself, I'd want to thank everybody for the opportunity to share with you Ekotrope today. And if there are any additional questions, you can always reach us. I'm just going to pull back up our presentation here so we can see the so that we can, you folks can contact us at the end here. Again, Bill Flynn, our Vice President, and myself, Head of Business Development. You can reach out to us anytime via the internet, via email, or via phone, or check us out on ekotrope.com. We'll also put up this webinar online so everybody can view it on YouTube. Thank you again, and hope to hear from you all soon.